Well, hello and welcome back to the channel. This is part 4, dealing with the electronics of the Nova SM3 robot dog. Here again are the links to the various websites that hold the information to build a Nova. So we're going to start by setting the 12 amp buck converter. This buck converter has got constant current CC and a constant voltage pot. So I've got 12 volts coming in, and I've got about a 40 ohm load on the output. The load is there purely just to make sure that I'm winding the constant current pot the right way. So we don't need the constant current function, so I need to wind the constant current potentiometer clockwise. If I wound it anti-clockwise enough times, we'd see that the output voltage would drop off to 0 volts or something like that. So I'm going to move the constant current, or the CC pot, clockwise, most probably 20 or so turns, until I can hear it going click click, which means it's at the end of its travel. So that's wound the constant current control out of the way. Now I'm going to use move the constant voltage pot. So I want to set that to about 6.8 volts. So right now it's 11.38 volts, so I need to lower the voltage, so that I need to turn that pot anti-clockwise. So mostly 10 times or so, 10 rotations. And we're just starting to get the voltage to come down now. So now I've set that to 6.8 volts. Now we'll set the 2 amp buck converter. This doesn't have constant current control, it just has a constant voltage control. Again, I just have 12 volts going into the buck converter. When it's in circuit, it'll come from the other buck converter, so I only have 6.8 volts, but that doesn't really matter. Now I'm going to set this one a little bit lower than what they say in the specs. I'm going to set it to 5.2 volts, because some of the devices, like the PIR and the ultrasonics and the MP3 player, they don't like much over 5 volts, so I'm just going to set this at 5.2. That should still be okay to run the Nano and the Teensy. Here again, because it's high voltage, I'm going to wind it down, so I'm going anti-clockwise. So now that buck converter is set as well. So now we can safely put those in circuit, knowing that they have the right output voltage. Now just a little bit about the printed circuit board. So I'm using printed circuit board. I got this through the link that's on the Nova SM3 webpage. When you click on that, it opens up the PCB Way website, and everything's set up. You just need to order the boards. This is just as default. You can change colours of the board and things like that. A little bit about the JST connectors. So the website, Nova website, suggests you make them yourself, but I just found some that was already pre-made. These are 300mm long, 26 AWG. So I brought some 5-pin, 4-pin, 3-pin and 2-pin. I think there was 10 of each of the plugs except for the 2-pin, and I only had 5 of them. One of the 4-pin needs to be 400mm long, so I had to join mine, but if you get a 400 or 500mm long one, that would be even better. So these also come with the PCB socket, which is handy, so that's what you fit into the printed circuit board. You also need some servo extension leads, so sometimes they're called dew point 2.54. Dew point 2.54. You need 6 of these. Well, where I mounted my PWM controller card, which is at the rear, so the front 6 servos need extension leads. I guess if you mount this PWM in the battery tray, you may need a different arrangement of leads. So here's the printed circuit board. I've fitted the components in. Now I've also put sockets on the Nano and on the Teensy. It's going to make life a lot easier in case one of them fails. I can easily replace it. I mentioned this in the video before, but I'll talk about it again because we're talking about the wiring. When we're calibrating Nova servos or running Nova without a remote control, we need to have a computer with Arduino IDE plugged into the USB port of the Teensy 4. So the USB port will be supplying the Teensy 4 with 5 volts, and also the buck converter via the V-in to the Teensy will be supplying 5 volts. So there will be a conflict of voltages there, which may damage the computer USB port. So to fix that up, we need to cut this track on the Teensy, and that will separate the USB port supply from the V-in. So there is a video that explains it maybe a little bit better, and I'll put a link to that in the description. Now the Nano doesn't have that sort of problem, so we don't need to do any changes at all to the Nano board. So I've created a couple extra circuit diagrams. These are available from the Thingiverse project, where the modified 3D printed parts are. And I'll put a link in the description to that Thingiverse project. So first up, this is the power wiring. So left hand side, the battery connected to the switch, and the switch comes in here and it goes to the VLT divide printed circuit board terminals. There's 2 resistors that act as voltage dividers, so the Teensy can read the battery voltage. So the battery also goes to the 12 amp buck converter. The output of that comes back into the printed circuit board through the 6.8 V-in terminal, which then branches out to a couple terminals on the printed circuit board. So these are at 6.8 volts now, so one of them goes to the switch on the rear panel, so that turns to 6.8 volts on and off to the PWM driver, so you can turn the servos off. Also goes to the LED voltmeter. Another one goes out of the printed circuit board terminals to the 1 amp or 2 amp buck converter, and then that comes back into the 5 volts V-in terminals on the printed circuit board, and then that gets branched out to various other terminals on the printed circuit board that drives anything that needs 5 volts, like the Nano and the MP3 player the ultrasonics and the PIR. Second of the new drawings is the wiring loom. So I've got the individual components and the connections to them that go to the JST plugs that plug into the printed circuit board. By way of example, the first RGB D in goes to pin 3 of the RGB plug, and that goes to D2 of the Nano. You also see there that the RGB supply also goes to the OLED display, because both of them are in the front or the face panel. I've separated the PIR 5V supply that did go to the switch panel, so it made it hard to remove the top cover. So I've now separated them using the 5V GND1 plug. The servo driver board with the I haven't labelled the 6.8 volts because that comes from the switch on the rear panel. The MP3, which comes from the Teensy, here highlighting that the TX on the Teensy becomes the RX on the MP3 player, and the RX on the Teensy becomes the TX in the MP3 player. We've also got here the NRF 24LA1, that's reasonably straightforward wiring. Now the last of the drawings, this is just a layout of all the communications. By way of example, the serial UART on the Teensy that drives the MP3 player, and the NRF 24LA1 that's on the SPI 1 bus of the Teensy. You shouldn't really need any of this, but it's just something that I guess nice to know. If there is any problems with the communications, you can have a look at this drawing. A general overview of the wiring. We'll start with the head panel. So that has the ultrasonics, RGB LEDs and the OLED panel, which is fitted into a modified mid panel. So the wiring loom is one 4-pin plug, 2 3-pin plugs and a 2-pin plug that runs back to the printed circuit board. The RGB LEDs are fitted into LED mounts, so I'll put a link in the description about those, as well as the modified mid panel to fit the OLED. So now the rear panel. I found this picture, I think it was on Discord server. They suggest using pots with knobs on them, but they were hugely expensive and very hard to find, so I just used ones without. I don't think we'll adjust them very often, so they'll be okay. The big switch is connected to the battery and isolates the battery from everything else. So I haven't tied any of the wiring down yet, so all the looms are still hanging around. I'll get some cable ties on there. So this is the modified part to hold the PWM servo board. So that's at the rear Nova. and the other modified part that holds the small buck converter. And that's the MP3 player, the Pro version. Now I've cut some of the chassis away here to fit a USB plug. The plug is at 90 degrees, and I'll explain that when we do the calibration. So the underside of Nova, the centre section is where the battery will fit. See that the front 6 servos have got extension leads on them, otherwise it wouldn't reach the PWM controller card, which is sitting at the rear. But the rear 6 servos, the length of those cables are okay. So this is the extension cable that I had to make up for the rear panel. That was 300mm long, but they should have been 400mm long. So I just put a joiner in there. It'd be easier if I just brought a 400mm cable. So we've got the large buck converter there, the 12 amp one. The Teensy up there and the Nano down on the lower section. So this is the top panel with the PIRs in them. As mentioned before, I separated the power and the signal so I could remove the cover. I just used servo or dew point connectors that plug straight into the pins on the PIRs. Just put a little bit of text on there just so I remember if the plug falls off how to hook it back up again. These are modified cups and that, they're a bit stronger, so when you put Nova upside down they don't snap off. Again, those files are in Thingiverse project. The NRF24 is mounted with a 8-pin dew point connector. Because it can be put at either side, I've put a white dot on there just to line it back up so I don't reverse the polarity or anything like that. You see the 22 UF capacitors also fitted to the power supply on their power pins. It's just free floating at the moment. I think I'll mount it under the MP3 player. It just depends how much, where the least radio interference comes from. That about wraps it up for the electronics. So the next one will be part 5, which is calibration of Nova. So until then, thank you for watching, and we'll catch you next time.